Transformers have become an integral part of generative AI, and a lot of innovation is happening around them. We even have vision transformers now, which are proving to be very instrumental when it comes to computer vision. In this paper, which is titled What Do Vision Transformers Learn? A Visual Exploration, these researchers, Amin Ghiasi, Hamid Kazemi, Ethan Bognia, Stephen Reich et al. At University of Maryland have done this great work on visualized representation learned by a vision transformer. These researchers have compared their results to earlier visualization of convolutional neural networks or CNNs. We know that these vision transformers have delivered state-of-the-art results in several domains of machine learning, but we really don't know what really goes on in these CNNs. That is where a method has been used to visualize the internal workings of these convolutional neural networks or CNNs. This method has revealed as part of this research that what exactly happens inside transformers, which is feeding the network images that maximize the output of a particular neuron makes it possible to determine what individual neurons contribute to the network's output. Now, the way they have done is that they have used pre-trained WIT B16 vision transformer and then they selected a neuron to visualize. Afterwards, they fed this WIT B16 an image of a random noise. And then they used a loss function that maximized the neuron's output, and then they back propagated through the network to alter the image. Alongside, separately, they fed every image net image to WIT B16 model to find one that maximized the same neuron's output. And then they compared the image they found with the generated image to identify commonalities. Now, this WIT B16 transformer is fully connected layers were most revealing. Neurons in fully connected layers yielded images that contained recognizable features, while those in attention layers yielded images that resembled noise. The reason why I think that this is quite a groundbreaking finding is that because vision transformers base their output on hierarchical representation in much the same way that CNNs do, but they learn stronger associations between image foregrounds and backgrounds. Since such insights deepen our understanding of vision transformers, and then they can help a lot of other researchers explain their outputs, especially when we are using such models from places like Hugging Face. I hope that you found it interesting. I will drop the link to this paper, and you can read this abstract, and you can also read the paper on this right hand side by downloading this whole PDF. Let me also quickly show you this PDF. So this is the PDF of this paper, and you can see that they have given some of the examples of these images with the edges, texture, and all of these they have fed into that model which I was discussing in WIT B32. And then there are a few more examples, and they have explained it in a very nice language which you can read through. And they have also compared it to the previous work which I mentioned earlier in the abstract. Okay, so that's pretty much it. I hope that you enjoyed it. If you like the content, please consider subscribing to the channel. Thank you.